Good so far? Everybody with me? Okay. Now, we have the universal functions with Boolean masking. Okay, remember, we did Boolean masking for indexing and slicing, where we specify a condition, and if the condition is satisfied, that row or that column is selected in the slicing. So we can do the same thing here, and this is very useful when you want to count how many numbers satisfy a particular condition in a column. Suppose if you have a column of age and you want to see how many people are older than 40, then you can put that condition, you say sum. So the condition is not satisfied, you will have 0. The condition is satisfied, you will have 1. So the sum will give you how many people are at least 40 years old, and so on. Okay. So here is an example. So we have ARR2D6, and we want to know how many numbers are positive, or how many numbers are not negative. Okay. How many numbers are, well, it's actually positive because we are strictly greater than 0. So you specify the condition. So here you have within parentheses we have a condition, and then you have dot sum. So it's going to, this will give you zeros and ones. So, well, false is 0, true is 1, right? So this is going to go through each and every one of the numbers here, and it will give you either true or false for that condition. Okay. Now you're going to do a sum, then it's going to give you the number of true here. Yeah. And you can specify axis. If you do an axis equal to 0, so it will go through by row by row. Okay, you take the first column row by row, how many are positive, second column, how many are positive, and so on. So and then we have a couple of any and all. Again, these two functions are useful to see whether there are any missing values in a column. So if you have a column and you want to see whether there are any missing values, then you can say any, or one possible application is for missing values, but you can use it for any condition. Any is used to see whether there are any value, even one value, that meets a particular condition. And then all is used whether all the values meet a condition. So if you want to see whether all the values are valid values, then you say, okay, is the condition that you want is whether it is not equal to a missing value. If even 1 is the missing value, then you're going to get a false result. Okay. So here this one is ARR2D6 greater than 0, any. Are there any number that is greater than 0? Okay. So yeah, true. And if you do a sum here, it will give you 1. Okay. Now, the same thing, if you use instead of any, if you have all, so now you are saying, are all numbers greater than 0? And obviously that's not true, because there are some negative values. Okay, here is a case where the condition is not really the same as greater than 0. So you can, what we are doing now is we are seeing whether there are any numbers that's outside of -1.1 to 1.1. So you take the absolute value of the numbers and see whether any number is greater than 1.1. and we want any here along axis 0, so it will go through the rows from each column and apply this function and see whether there are any one number that is so. Okay. All right. So now your turn. Answer the following for ARR 2D6. So let's put that, and then count the number of elements with absolute value that are at least 1. Okay, at least 1. So how do you do that? Okay, so we can say ARR 2D6 okay. So the condition is, well, let's do it like this. ABS okay. So np.abs ARR2D6 is going to give you an array where all the negative numbers are changed into positive numbers. So now we have absolute value. Now we want to see whether we want to apply the condition to this result, right? So here we want at least 1. At least 1 is greater than or equal to 1. Okay. So that's going to give us either true or false. Now we want to count how many are there, right? So we have to sum this. To sum this, we need to put parentheses around it and then do a sum, right? Okay. Now, of course, if you use access here, then you will have so find the mean of non-negative numbers in each row. Okay. So non-negative numbers in each row. All right. So how would you do that? So ARR2 D6. Okay. Okay, so we want non-negative numbers. So that means what? Greater than or equal to 0. Non-negative, because 0 is not negative. So this could change, because if there is a 0, then the mean will be different, because you'll have one more number there. So you have to specify that. So that's our condition. Okay. And then, again, remember, this condition will generate a NumPy array. So this mean here would be NumPy mean, NP mean. So this tells us that this is an NP data object. So mean will be universal function mean, and we want that for each row. So each row means you have to go through the columns. So axis should be 1. Okay, so axis 1 will go through the columns. Okay, so this one is A, this one is B. Okay, C, determine whether there are any negative numbers in each row. Are there any negative numbers in each row? Well, we can do it several ways. What we're going to do is use any function. So ARR2D6 less than 0. Okay. And then we can use any. So if you just simply any will be, it will go through the entire array, but what we want is each row. So this here axis should be equal to, so each row means you have to go through the columns. So axis is equal to 1.